Sketch on the complex plane the region defined by mod z minus 3 minus 4i is less than or equal to 5 over 2. Now I like to rewrite that in this way here. You should recognize this as being a circle. By rewriting it like this, we can see that the center is at the point 3, 4. The radius of the circumference is going to be 5 over 2, and then the less than or equal to means we're shading inside that circle. So let's have a sketch of this. So put the real axis along here and the imaginary axis up there. And 3, 4, let's say that's here. And our radius is 2.5, so it won't come quite over to here, like that. So it's going to look something like this. And the center there is at 3, 4. For the region in part A, we need to shade inside. Sorry, forgot that bit. So for the region in A, find the maximum value of mod z. So that's going to be the furthest distance of any point in that circle from the origin. Now, the way to do this is to take a line through the center of the circle right the way across to the point on the circumference over there. Now we can form a right angle triangle here. We know this is 3 and this is 4. So this is 5. And of course the radius is 5 over 2. So the maximum value of mod z is 5 plus 5 over 2, which is 15 over 2. The minimum value of mod z, well, that is going to be at this point here. So that's the closest to the origin that the circle gets. And we know that this distance, the hypotenuse here was 5, and the radius is 5 over 2. And so it's going to be 5 take away 5 over 2, which is 5 over 2. We now want to find the maximum value of argz and then the minimum value of argz. So argz is the angle from the origin. So I'm going to look at both of these together. So if we go to a tangent to the circle here, that will be the minimum value of argz. If we go to a tangent to the circle up there, that will be the maximum value of argz. So if we put the center of the circle back in here, we can then draw a radius to where that tangent touches, and we'll do the same sort of thing over here. So radius to where it touches. And of course, we know that the radius is 5 over 2. Let's do a line from the origin to the center of the circle. And as discussed in the other part of the question, we know that that's of length 5 because the center is at the point 3, 4. We also know that this will be a right angle. Therefore, if we consider this angle here, which I'll call alpha, we can say that sine alpha is 5 pi by 2 divided by 5, which is equal to a half. So alpha is actually pi by 6. Now I'm actually just going to quickly produce a second sketch down here, just so that I don't have too many lines on the one up there. So here's the circle. And we know the center there is at 3, 4. So if we form this triangle, this is 4, this is 3. And if I call this angle here beta, and on this diagram that would be the whole angle from the axis to that line, then we can see that tan beta is equal to 4 over 3, and therefore beta is the inverse tangent of 4 over 3. So let's do the minimum value first. We're after this angle here, which is clearly beta minus alpha. So this one is beta minus alpha, which is tan to the negative 1 4/3, take away pi by 6. Now to get the maximum angle, it's going to be this angle here, the beta on this diagram, plus the angle here, which, because of the symmetry, this shape up here is a kite. This angle here is also alpha, so that one's also pi by 6. And so this one is beta plus alpha, and therefore is tan to the negative 1 4/3 plus pi by 6.